Good day to my panel. Today I would like to present about my final year research entitled as Blue Water Footprint Determination and Prediction of Heavy Industrial Activities in Kuantan River Basin by D. Nur Fatina Aina binti Cik Hamzah VA with ID number AA16145. I'm doing my PSM under the guide of Dr. Adriana binti Abdul Aziz together with 5 others. My presentation consists of 10 parts, which are introduction, problem statement, research objective, scope of study, significance of study, literature review, research methodology, result and discussion, conclusion, and lastly, introduction. Water footprint. What is water footprint? It is a study on how to measure the volume of fresh water consumed in producing every services or things around us for our convenient lifestyle. For example, production of jeans, growing paddy to make it rice, and etc. Blue water footprint, volume of water used and evaporated or added into a material in terms of consumption, either from the surface or groundwater, which is not returned to the reservoir from where it is drawn. My study is only focusing on how to determine the total number of blue water footprint that was produced from heavy industrial activities in Kuantan. Problem statement. The main source of water consumption for industrial activity is from the same water treatment plants shared with other sectors such as domestic and agriculture. Particularly in Pahang, there are so many types of industry existed to meet the economic demand. There are issues such as on how many actual consumption used by industrial activities, especially heavy industry compared to domestic usage itself, caused the percentage water footprint to increase into 19.9% in 2016 compared to 2015, which is 1.8%. This problem has led into water shortage problem for Kuantan residents. There are 3 research objectives, which is 1. To inventory heavy industrial activities within Kuantan River Basin area for 2015 until 2018. Objective 2. To determine blue water footprint of heavy industrial activities in Kuantan River Basin for 2015 until 2018. And the third one is to predict the total water footprint for every heavy industrial activity based on deep learning. Scope of study. The study location is in Kuantan River Basin. There are 5 water treatment plants in this area that are responsible for industrial activities, water distribution. First is water treatment plant Semambu. Second one in Sungai Lembeng. Third one in Sungai Pancing. The fourth one is in Bukit Ubi, and the last one is Bukit Sagu. Water footprint consists of 3 types, which was blue, grey and green. However, my study focused on blue water footprint only. Deep learning predict the blue water footprint in heavy industry by using the method of backpropagation. Backpropagation method is a method that use the previous past data to make the prediction. And the study focus on heavy industrial activities only. For example, of heavy industrial activity is textile, mining, petrochemical, etc. There are 5 significance of study, which is first is benefit of blue water footprint to heavy industrial activity, whether improve or worsen. Prediction of water footprint content can be determined based on type of heavy industry water consumption. The option the sustainability result of blue water footprint as the water consumed must not exceed the freshwater source of limit. However, the blue water footprint will benefit the people which is consumer in this study. And the last one is to make sure that the Kuantan River Basin is resource efficient to be shared fairly among all the regardless users. This is the example of literature review that I read from tons of journal. Research methodology. For this study purpose, Kuantan River Basin has been chosen as the area to determine the industry that get water supply from the water treatment plant around Kuantan. Kuantan River Basin area coverage is 1,638 km square. First methodology to be done is by setting up inventory from the list of licensed heavy industry sector within Kuantan River Basin. This data will be collected from Kuantan Municipality. And then this is the step to be done. First is data collection, inventorying of data cleaning, data classification based on types of industry, and classification area. All the data is done in Microsoft Excel. For the objective 2, blue water footprint for heavy industrial activities is determined by using the formula established by the footprint network. The last one is the modeling. Modeling water footprint for heavy industrial activity will be assessed by using deep machine learning. First thing first is we need to do the result classifying, cleaning data, removing of outliers, normalization of data, optimizing at hyperparameter, construction network architecting and validation, and lastly publish model. Talks and discussion. In 2005, there are 69 premises of total heavy industry activities was found and was recorded in the list. Among of 69 premises, there is 21 premises that is dominating because they operated some activities because consumer for water intake that is manufacturing. There is a sudden surge of number of premises which increased about 4 premises compared to previous year. 2016 recorded 73 premises that operated in the area. This sudden increment is influenced by the factor that there is a high demand in this industry, increasing in population of people and more. Manufacturing sector is still dominated as the biggest sector out of all activities listed in this area. From 2 years previously, we can see that the trend for the premises is increased in number. In 2017, the number of premises operated actively is suddenly decreased to 67 premises only. The number of premises operated even though the number of premises is decreasing, manufacturing sector still holds as the biggest heavy industry activities that actively operated this year too. The decreasing in number of premises can be explained whether their operation already ended due to various reasons like high competition or they already moved their premise to another place. And start to increase again in 2018 even though the increasing in premise from 67 previously to 68 wasn't significantly noticeable. They still gave a huge impact toward the consumption. Since we know that manufacturing sector is a sector that uses a lot of water from the water treatment plants, and they have predominating for 4 years straight as the biggest sector to consume a lot of water intake to fulfill their demand. Objective 2 is to determine the blue water footprint of heavy industrial activities in Kuantan River Basin for 2014 until 2018. Based on all 5 water treatment plants, it can be seen that in year 2018 for all water treatment plant, the total blue water footprint for heavy industrial activities are the highest compared to the other 3 years. Semambu and Bukit Ubi both shared the lowest total blue water footprint, which is in year 2017. Bukit Sagu water treatment plant recorded the lowest blue water footprint in 2015. Pancing and Sungai Lembeng also has the lowest total blue water footprint, which is in year 2017. It already been known that in 2017, the number of premise operated is at the lowest compared to the other 3 years in the time span of 2015 to 2018, which is why the number of total blue water footprint also being affected here. Objective 3 is to make the prediction by using the deep learning algorithm. Bukit Ubi, Sungai Lembeng, Pancing, Semambu, uh, four four water treatment plants that share the same trend. For all of these water treatment plants, the prediction data is lower compared to the actual data because of the existence of outliers. The actual data fluctuate a lot because of outliers. If the data used of blue water consumption is in daily, not monthly, the deep learning model result will be more better since the gap is decreasing. The smaller the gap, the better the result. the better the accuracy that we can get for the prediction. To be mentioned is before we use this modeling, we there is epoch. Epoch is a term used to indicate the number of pass for the entire training data set in the machine learning, and it was set to 50. For the last water treatment is the Bukit Sagu. The reason why Bukit Sagu is the only water treatment plant with high prediction data is because the number of activities recorded there is the lowest compared to the other for water treatment plant. The lowest the lower the industrial activity recorded, the higher the prediction of data. If If the prediction is high, it meant that to control the industry consumption so that in future it won't be a reason that the country is facing water scarcity. And also, this modeling, previously the modeling was about the selection of the best hyperparameter. However, due to the MCO period and after discussing with supervisor, we changed the method to the long short term um, machine, a time series prediction. Long short-term modeling, a time series prediction. Modeling is just a small part of this research which use application and code that already there. So for the conclusion, the main goal of this study is to determine the blue water footprint that exists in every heavy industrial area around Kuantan River Basin by using deep learning algorithm. The result for objective 1 and 2 can be analysed by looking at the graph trend that indicate which year is dominating for both total heavy industrial activity and total blue water footprint. Therefore, the final result for the prediction and determination of blue water footprint for heavy industrial activity in Kuantan River Basin, which was using deep learning algorithm, is presented in the form of figure 2 to show more clear changes that occur. And this is an example or reference that I take from my thesis. And that's all from me. Thank you.